Hey everybody, this is Alex Merced from alexmercedcoder.com. And what I want to do today was talk a little bit about more Go. Okay, so I think this would be day 11 or 12 of our 100 days of Go. And today I want to just talk a little bit about not Go, I mean Go and Rust. So 100 days of Go and Rust. And what I want to talk about is error handling. Just a little bit about like the aspects of like how do errors work in these languages. Not a deep dive, just kind of a shallow look. Okay, so bottom line is this. Let's say the way error handling is generally done in Go is that a function is written to return two values, either the value you want or an error. Okay, so let me just go ahead and refer to the example here because I need to import errors. Okay, so errors. Okay, and it's going to complain. Let's write a function. So let's just say func error example. Okay, and then it'll just take in a num, which is an integer, and it's going to return an int or an error. Okay. And then let me just put the curly brackets here. Okay, undefined error. I think this is supposed to be error. Nope. That's the example here. Int error. Oh, lowercase. So close, so close. Okay, so the idea is that this is going to return an integer or an error. So I'm just going to say if num equals 5, then return 1 and nil, meaning it's successful. We're getting back a sufficient value. So I'm going to get back the integer of 1 and no error. Okay, that means it was successful. Else, return -1. Okay, so that way it's falsy in a sense. And then we do error dot new, or actually it's errors dot new, and we're going to say you did bad. Okay, so there you go. You have a function that can throw an error. That's essentially what you would do. You would just say this function can either, again, give you a value or throw an error, and then you make sure you return the two values necessary for the outcome that you want. So let's see here. So then what you would do is you would say, I want to use a function, so I'm going to declare a variable. So we'll say cheese equals the result of error. What's the name of the function? Error example. Error example, and then we're going to pass it. First, we're going to pass it the number 5, so that way we get an error. Okay. And then here's where I made a mistake. Basically, it returns two values, so I need to make sure I declare a variable for both values. So this would get the successful value, this will receive the error. But here's the thing, I have to make sure I use error. So that means I have to check if the error exists. Okay, so I can say if error does not equal nil, meaning I got some sort of error, then I might just fmt.println the error. Okay, and if not, then we will else all as well. Then we will fmt.println cheese. Okay, then that's the deal there. So basically, I just, if I have to receive it, if a function returns two values, I have to make sure I receive both values. But I have to make sure that both values are used. So typically, I'm going to go do an if statement to check k is the error or something. Okay, I have to make, so I'll do an if statement, check k, is there an error, then handle the error if there is an error. I think they were going to try to come up with some sort of like more straightforward way of doing that, but I think right now you still just have to write the if statement. You just kind of have to just check, hey, is this thing a thing? I mean, you just have to use the variable, bottom line. Okay, or else the compiler's going to be like, hey, there's an unused variable, and I have to declare it. I mean, the other option, I think I can just do, well, first let's just run this code. So let me open integrated terminal. Go run.go, and see I get 1. And let's say I change it to, wait, I got 1? I shouldn't get 1 because I gave it the number 5. And if number equals 5, so that was the correct number. Okay, so let's try it with some other number other than 5. Okay, and see I get the error. Okay, so that is generally how that would work. But what if I really don't want to have to check for the error because, you know, I want to be lazy about it? I'm pretty sure I can do this. I can just make that an underscore, and that just kind of ignores it, and then I can just do fmt.println cheese. Okay, and you see I don't get any more errors because when you do an underscore, it's basically just saying, hey, I'm ignoring that variable. So it's there, but I don't want to use it. And see I get -1. Okay, which is another reason why you might want to use a -1 in that error example, so that way there's at least something to kind of tell, like, hey, there was an error, if someone decides to just ignore the error and not handle it in that regard. Okay, so that's essentially, if you run how you would write a function that throws an error. Okay, and 2, how you would handle it. Okay, not too bad. I think the way Go does it is pretty straightforward. Rust has some pros and cons. Writing a function that throws an error is still a little tricky, mainly because you have to like know the different error types. But essentially, it works like this: you would say function error example, okay, and then I'm gonna just again take a num that's i32, and then again we have to define the return value, and the return value would be a result, okay, and the result has basically returns two tuples, or two tuple structs. An OK tuple struct, which means, hey, you got the value you wanted, and an error tuple struct. So it would essentially be, you know, I32 will be what I want to send in the sum, and then I want to say error, but just say error there, okay? And then that's the deal there. So basically, I have to return one of those two things. Okay, and then we'll just kind of do the deal. If, okay, now if num equals 5, just like we did before, what I want to do is return an OK tuple. Return OK with, let's say, 1 inside of it. And else I want to return error with you did bad in front of it. And this is generally not the best way to do an error, but just to kind of show you that it works-ish. I'm pretty sure I'm going to get some errors here. There's still some questions I have about exactly, like this is all fine and good. Let me just go back and take a look at the sample here. Didn't really show you a good sample of writing a function. Like here you go, so let's say like string, okay, and then error. Okay, we'll see if this works. Okay, so then I will use the function in here. Okay, and we would declare a variable, so we'll say like var, oh, actually, yeah, say var let, or actually I can even just do a match. So we would just use the function error example 5, and I would match that. So match error example 5, and then I have to kind of list all my possibilities, because again, it's going to either return the OK tuple or the error tuple, and there's no way for me to magically know, so you have to use structural pattern matching. So I would just be like, okay, if it's an OK tuple, so then we'll store the return value as S for success, and then we'll just say println S. And if it's an error tuple with an error inside of it, we'll just println the error. Okay, and then that's pretty much all I really want to do. I'm sure I'm probably want a semicolon somewhere. Let me just think if there's anywhere. Maybe not. I'm not using the hash map anymore right now, so let me comment that out so I don't get any like it's not used errors. So let's open that in the terminal and compile the file rustc run.rs and then run the file /run. Okay, yep, figured we get something. So let's run through the errors. Oh, that's a lot of errors. Okay, format string must be literal. Oh yeah, that's right. Boop. It's actually interesting the way this. I've been reading up on how the macros work. So like how you set up these like print line macros. It's pretty interesting. I'm not gonna do a video on it yet because it's quite complicated. So I just want to play with it a little bit more for make sure that I have wrapped my head around it. But essentially, it's actually kind of using this pattern here to determine how many arguments. Because essentially, what it's doing, it's creating a function that'll print the text with the arguments that you put in. But again, you can't in Rust you can't have a variable number of arguments. It's just not a thing. So what you do is you have to create a macro that looks at some sort of pattern to determine how many arguments there should be, and essentially at compile time, it will then write that. It creates that function and then compiles it, which is actually pretty interesting. And again, essentially what these macros are, when you see like these exclamation points, they are things that essentially, they're basically functions that write code. They run before compile time. And instead of like doing something in the program, they output code that is then going to be compiled afterwards. So basically you're automating the writing of code. Okay, so there's that error. Let me just take a look through some of the other errors. So we took care of those two. Cannot find type error in the scope. Not found the scope. Consider importing one of these. Okay. So we'll use this. Or actually, yeah, let's use that. So I'm glad like it gives you like I love the Rust compiler. It gives you great suggestions. Copy. Use one of these. Yeah. Okay. So that we're importing the error type. Cannot find OK in the scope. Help. A tuple variant with a similar name exists. Oh, capitalization. See how good it is? It's so good. I love that. Okay. Error. Okay, and again, see that should be uppercase. Error. Okay. Cannot find a tuple with a struct variant. Okay, and then again, I have to do the same thing here. Those tuple names, again, they're types, so they should be uppercased. Okay. Oh, yep. You don't need the parentheses for if statements for either of these languages. JavaScript habits die hard. Okay, I think we addressed most of those. Oh, we still got something. Help the trait size. Help. The trait size is not implemented for dynamic standard error plus static. Okay, does it give us a suggestion? Error help use dynamic error. Okay, so let's try that. So that's like a dynamically sized error. This was previously accepted by the compiler, but it's being phased out. Warn bear trait objects on by default. Okay, so let's try it again. We took the suggestion of the compiler. Okay, it doesn't have a size on a compile time, so it doesn't like that. Okay. Trait size. I'm assuming this is why in the example, if we go further down, they use a box. Okay, I haven't covered boxes yet, but boxes allow you to kind of define like memory on the heap. And again, the idea is that Rust by default is always going to allocate memory on the stack. That's kind of why it's so fast, because it tries to use the stack as much as possible and make it where and that's the same thing that makes C so fast. You always use a stack unless you go out of your way to allocate memory on the heap. And again, the stack represents like the stack of pancakes or stack of functions that always works its way down. So basically, when a function's done, anything it created is kind of cleared out. That's faster, but then what happens if like a function finishes, it gets cleared out, but you needed something it created somewhere else? And that's where the heap comes in. I can store something on the heap before, so even though the function resolves and clears itself out, the variable's still in the heap. So in that case, when I need things to exist across dimensions, I need the heap. So in this case, that's what it wants me to do here. So let's try that out. Okay, so let's go over here. So I've used the box once or twice before. It's been a while, so I don't remember exactly like how I used it, but let's try that out. Let's see here. Does that make sense? Box, dynamic error. Oh, I see. There's this. I have to close that out. So it should look like that. Let's see what it says. Okay. Found at string. This in the heap. Ah. Okay. So wants me to do is say box new. You did bad. So the idea is that the box is the memory on the heap, and then in that memory in the heap, I am storing this string, so that way I can refer to it. Okay. I have a feeling what's going to happen is I'm eventually going to have to put in that colon question mark here, but I want to see what the compiler says first. Okay. Trait is not implemented for stir. Require that you cast to the object type. Standard error for note required because requirements of on implementation. They're making a suggestion the trait is not implemented for string. Okay. To the object. Standard error. Okay. So what if I do this? In here, I do error. I'm going to assume that there's going to be a constructor for that. And then maybe there I put the string. You did bad. Okay, and let's just see if that does a thing. That's gonna be my assumption, because like the pattern always is there's a new function implemented on every associator not found in okay, let me just see the problem is again in the documentation. They really show a good example of how they use the box there. We just see that. Okay, and the reason is because they're using this question mark. So you remember before, like you would have to do a match and all that stuff. What it's doing here is that it's basically this acts as like the if. Like if there's an error, then handle the error, or like, you know, do the error thing, or return that. And then if not, then it just moves on. So then in this case, F would then store the results of this if this succeeds. If not, then it just returns the error. So the trait object, which we'll call about using trait object, blah, blah, blah. We've discussed details in calling panic. Okay. So what I'm going to do is function associated not found. So let's just do this then. Error. And just put in curly brackets, just declare an error that way. Not a struct, variant, or union type. Coin. Yep. But we are importing standard error. Now what is it saying? Import. Consider importing the struct instead. Standard format error. Okay, let's try that. Copy. Paste. Okay, not a trait. Oh, now I remember what the dynamic keyword is. Okay, so what the dynamic keyword does, okay, because I remember running into this before, is that if you have things of multiple traits, so error is a trait, and what it does, it allocates memory that's the size of the largest struct that implements that trait. So that way you can, so that this way, if like you had many different structs that implement a particular trait, you could say, hey, I'm going to return one of these. That's, now it's coming back to me. No, but I just want to store an error in there. Okay. Okay, looks we're running, so that's good. Okay, example help convert the identifier to snake case, of course. That's what it's complaining about. So now we're working. But see, like writing a function that throws an error is a little bit trickier in Rust. But you can see here standard format error. We threw the error. Now I want to see what happens if we use a number other than 5, and we receive the error. So again, when we've succeeded, we got the 1, so that works. Okay, now we'll see what happens now if we do 1, and we would be throwing the error instead. Okay, and then I have to change the name of the function here, because I just made a camel case. An error occurred when formatting an argument. Okay, so like that's not exactly the error I wanted, but it threw an error, and that's where it gets tricky. Like you have to know which type of error you want to throw, and then pass in that error. But at least you got the idea. And then now here's the thing. So see, when you have a function that returns a result, it's going to return either again an OK or an error. And then you use pattern matching. But what if I don't want to use pattern matching? Okay, that's where that question mark symbol comes in. So I can then use like this, and then instead of using match here, we'll declare a variable. So we'll just say let cheese equal error example, and print line cheese. Okay, so let's see what happens when it's throwing an error. Okay, I didn't like that. Turns. The operator can only be used in a function that returns result or option, which this does. Error example returns result. Returns. I think it returns this. Confused. Because we definitely are returning a result. File open. Okay, yes, it doesn't really show you many examples to make this as clear as other things are. But I get it. It's complaining that like it's getting an empty tuple instead. And I think that's just because of the particular error type. But typically, if the function throws a result, I could use this question mark instead. And that makes it simpler where I don't have to do the whole match statement if I want to do a match every time. I'll play with that more. As you can see, like Rust is always just like it has a little bit more nuance. And again, it does that because it's trying to again keep as much of that memory on the stack. But it does certainly take some getting used to. But that's why I like the challenge. Okay, it's like I want to get better with this because it's going to make me a better developer all around in any language I type in, because it's forcing me to think so much about sort of the bare metal of how everything is working. And same thing with Go. That's why I like working with these two languages. And I find Go to be just sort of a very delightful language when it comes to trying to work in a more sort of lower level, faster way versus working with like JavaScript, Python, Ruby, where I feel super nimble and like I feel like a magician. But again, I could be more efficient with my usage of memory, which again depends if that's necessary for the particular application you're making. But again, I just find this stuff super interesting. So that's today's lesson. I'll see y'all later. Have a great one. Ciao.